Hello, everyone, and welcome to today's webinar. Thank you for joining us. We will be taking all questions at the end of the presentation, but please send in your questions through your Q&A chat box at any time during this webinar. So let's go ahead and get started. Hayes, would you like to take it away?
Certainly. Thanks, Marissa. Welcome, everyone. I know many folks are joining remotely today based on the current circumstances, so I want to thank everyone for dialing in and for participating in this webinar. So, Marissa, if you could go to the next slide, please. So during the purpose of this webinar is really to talk about a new initiative by the Federal Energy Management Program, or FEMP, that we're working with in coordination with our sister offices at the Building Technologies Office and the Weatherization and Intergovernmental Programs around technology validation. We're really looking forward to federal agency participation and input in this effort, and looking forward to telling you more about the effort and getting federal sites that are interested in validating some of the technologies we'll talk about on the webinar today, getting them more information and hearing your questions at the end of this webinar. So just a little overview of our agenda. We have experts on the line that will introduce themselves to talk about each of the three technologies we'll be highlighting today. But first, we're just going to give a little overview on what this technology field validation is, some of the benefits of participation, and then we'll have each of the presenters present on the three technologies. They're really going to cover a technology overview, as well as some of the site and host requirements for the federal facilities that would be hosting these technology validations. So the three technologies we will be covering today are building energy management controls, WISE building, thin glass triple pane commercial windows, and spray foam insulation. So wanted to just let everyone know that we held a webinar yesterday as well. The content today is the same as the webinar content yesterday. Just wanted to have some alternate times for folks. If you were on yesterday's webinar, you're of course welcome to join and listen in again today and ask any questions. But just wanted to let everyone know that the content would be the same. We will be handling all questions at the end through the question chat box. So feel free to type those in as we go along, and then each of the experts and others will be responding to them at the end. And then we'll end with some, after the Q&A, we'll have some information on how to follow up if you are interested in hosting one of these technology validations at your federal site, and how to learn more and get into more of the specifics. So next slide, please. So just as an overview on this partnership and what we're trying to do, as I mentioned, we're partnering in the Federal Energy Management Program with our sister offices across the Department of Energy's Energy Efficiency and Renewable Energy Division. So we're partnering with our Building Technologies Office, the Advanced Manufacturing Office, and the Weatherization and Intergovernmental Office to field validate technologies in both federal and state and local facilities. And so the goal is really to validate and move forward the DOE sponsored technologies from our R&D programs, along with our federal and state and local partners, to really validate these technologies and then to provide feedback to the R&D community. Next slide, please. So this slide is really just highlighting what we're trying to do here, which is the two-way communication. So while we are trying to give federal sites, in this case, an opportunity to validate some of the technologies out of our R&D programs and EERE, we're also trying to make sure that the federal sites and the user community is able to provide back information to the R&D, to the researchers developing these technologies. So you're a critical part of this and really helping to inform the research and development and really have that two-way communication. So next slide, please. So some of the benefits of participating, this will be a DOE managed pilot where you'll have access to after we've talked through if your site is a good candidate for the technology validation, meeting some of those technical parameters that the presenters will each talk about here today. We'll be able to have access to those DOE subject matter experts throughout the pilot, throughout the validation phase, through the installation and the measurement and verification. So we'll really help those SMEs will then help to gather the use cases and performance data and really understand how the technology is working in your specific application. We're hoping that these technologies can help you and agencies support your mission and really help us gain those use cases and develop how the specific technologies can support your mission. And I should say also that the 3 technologies we're focusing on here today, we're hoping these are just the beginning, and looking more broadly to look at this effort across additional technologies in the future, but really with a focused effort on these 3 technologies here today. So at this point, I wanted to hand it over to my colleague from the Building Technologies Office, Amy Jiron, and she'll be covering a little bit about what is field validation. Amy?
Great, thanks. Melissa, you can move to the next slide. Great. Okay, hi, I'm Amy Jiron with the Commercial Buildings Program in the Building Technologies Office, but rest assured, there are others from the Residential Buildings Program. Marc, LaFrance, and Eric Werling are also on the line with experts from our national lab to talk about the technologies. So field validation is a way that we install new or underutilized technologies in existing operational buildings in order to understand more about how they perform across many different metrics, including energy and comfort and cost. Once we've completed our study of these buildings, we do publish a case study to help others understand the performance, to inform additional research that's required, and also to help purchasing further in the future. So our field validation is structured with third-party verification included. So we have someone from the lab come in and do instrumentation and monitoring and data evaluation in order to publish that last case study report and to ensure that we're getting objectivity in the experiment or the study in the field test. You can go to the next slide, Marissa, thank you. So some of the metrics, as I mentioned, that we look at in these field studies are energy reduction, utility cost savings, occupant satisfaction, comfort, things like that. We also are looking at where these can be applied more broadly, what building types are the best for this type of technology, where are we going to see the most energy savings with the least disruption, what types of systems, HVAC, plugs, lighting, all of that. And then also, what are the maintenance and operation implications of the technology? Is it going to be extra work for facility managers, or is it going to be extra training? Will the operation be complicated or easy? And of course, what is the both upfront capital costs, but also the associated commissioning and operations and ongoing costs to the technology. Next slide, please. So as I mentioned, we have kind of a trifecta approach here. We have the host site, which is the building, probably the facility manager at that host site, working with the technology provider and the lab. And so the lab is going to, as I mentioned, collect data in order to understand the performance of the technology, but also provide some technical assistance to the federal agency or the commercial building owner or whoever might be hosting the technology demonstration. And then, as I mentioned, at the end, we'll definitely be publishing a case study. The lab will also develop the scope of the project. So what are the M&V objectives, the monitoring and verification objectives, to include all of the metrics that I mentioned before as an example. Also, is the site the correct site? So that's some of the help that all of you will have upfront from the labs moving forward if you raise your hand and volunteer to work with us. Next slide, please. So we added this slide before we knew what was happening in the world today. So this is our hopeful schedule. Obviously, things will change, and we'll address those on a case-by-case basis. But typically in a validation, it takes about 3 months to find the right site. It takes 1 to 2 months, depending on the technology, to install. You can imagine that a chiller is going to be much different from a software platform. The validation, the evaluation portion, the data collection and instrumentation can take, sometimes it can be very short and sometimes it's very long. It depends on the seasonality of the technology. So do we need to know winter conditions versus summer, and then the swing conditions? What's the biggest impact for this technology? And then at the bottom of the slide here, you can see an example final report from a previous validation that we did actually with GSA. So you'll all have these slides at the end. You'll also have a recording to refer back to if you need to. Feel free to click that link and take a look. Okay, so that's the basic, really high-level overview of what we do on field validation. And with that, we're going to have our three expert technology speakers tell you a little bit more about these three technologies. So I'm going to turn it over to Armando Casillas, who's going to talk about BEM controls. Armando, can we hear you?
Hi, can you guys hear me?
Great, take it away. Yes.
Thank you so much, Amy. Good morning, everyone. My name is Armando Casillas. I'm a scientific engineering associate at Berkeley National Laboratory, and I'm here today to present to you some exciting technology called WISE Building, which is developed by BEM Controls, a company out of Virginia. This field validation project is being conducted by myself along with Dr. Jessica Granderson and Dr. Guanjing Lin at Berkeley National Laboratory. Next slide, please. So this slide here is, your catch-all overview of the WISE Building platform. The WISE Building platform is a central multi-end use building system for small and medium commercial buildings. So, as federal agency sort of facility managers, you can see why this is sort of a valuable tool to have. Small and medium commercial buildings aren't really exposed to the same amount of automation and intelligence that large buildings are exposed to in building stock. So, this platform is able to provide single point access across many zones and devices, including things like thermostats, smart plugs, and lighting. On top of that, it provides you a customized dashboard and user-friendly control interfaces. You can see that on the top right. Here you have on the left, you have the mobile interface, which is able to show you statuses and devices across your building. And on the right, you have the desktop version and, sort of an example of a room thermostat, its current temperature, status, and things like schedules and set points for each given day or, hour. So with all of this, WISE Building is able to provide optimization, visibility into your building schedules and set points via these smart thermostats, lighting, and smart plugs. Along with that, can provide you things like demand response control, and overall BEM controls guarantees at least 5% whole building energy savings compared to a non-controlled building case, which is delivered through the smart control that WISE Building provides. Another highlight I want to show is on the lower right, you have a case study that BEM Controls has provided with the link right below the graphic, showing a building owner that wanted to cut costs on peak demand costs. And basically what BEM Controls and WISE Building platform were able to do was able to control the set points across the building and widen the set points during the peak demand time. And with that, provided the customer with some pretty substantial savings. Before case showing 3.98, about 4 kilowatts of max power demand. And with the optimized new sequence provided by WISE Building, gave the customer only half a kilowatt. So substantial savings if you're able to get all your thermostats and all of the building to communicate correctly. You can get some pretty cool stuff happening. Next slide, please. So this slide is an overview of the cost to implement WISE Building. The actual costs vary depending on number and type of devices, as well as building conditions, and are also somewhat flexible, given that the WISE Building platform, at least for the field evaluations purpose, will only be installed for 6 months. And I'll go over that a little more in terms of timeline in the upcoming slides. So the costs are twofold. You have the one-time costs and you have annual recurring costs if you were to keep the platform for an extended period of time. So the one-time costs are the purchase of these compatible off-the-shelf hardware. So you have things like smart thermostats, smart lighting controllers, IR controllers for split AC systems, and things of that nature. So these are devices that are able to communicate via internet, Wi-Fi, wireless communication, in which Wise Building can talk to them, give them a status, give them set points, schedules, and the devices can go and return that information back into the Wise Building platform. So with the purchase of these devices comes installation and commissioning costs. This is also a one-time cost. You see here it's around $1,500. And on top of that, you have the recurring software and analytics cost. So the software control cost is really giving you the web and mobile access to all the smart devices that you purchased through that single interface that I showed you on the previous slide with optimized scheduling and things like demand response control. The data analytics portion is basically providing the facility manager, building owner, or whoever's interested with full cloud access to their data, which also provides analytics and reporting for all the sensors that are being controlled by the platform, and makes that data available to the customer. So that's altogether is around $3,500 for the software and $1,000 for the data analytics per year. And I want to reiterate, this is an estimate for a 50,000 square foot building, and it could vary depending on the number of devices and the complexity of your building operations. Next slide, please. So this slide goes over the site requirements we're looking for in terms of the building that we see ideal for this field validation project. So we're looking for anything, just a small to medium commercial building, anything below 100,000 square feet. This could be a public sector building, office building, hotel, school, strip mall, things of that nature. Things that have sort of what we call a normal occupancy profile. Come in around 6, 7, 8 o'clock in the morning, leave around 8 to 9, 10 p.m. or something like that. So that's what we're looking for in terms of building type. We would also like a rooftop unit or air handling unit less than 10 years old, and able to communicate with a new Wi-Fi enabled thermostat. We would like to highlight that we really strongly prefer the current thermostats in the building to be manually controlled. And this is really important when we are going in to install Wi-Fi enabled thermostats. So in that vein, we would like the ability to upgrade to these BEM compatible thermostats and lighting controls, as well as have access to have the devices having access to a stable Wi-Fi network, or at least allow BEM controls to install a sort of adjacent Wi-Fi network just for the purposes of the control in the building. It's really nice to have the ability to install smart meters to collect data for sub-metering and additional analytics in the building, as well as having whole building gas usage and electric usage data, as well as peak demand data for the building for additional analytics. This is crucial for the historic sort of baseline that we create for the field validation project. We need at least 12 months of electrical and gas interval data to create that baseline and perform our measurement and verification. Other considerations I want to highlight is LB&L. The lab is available to work with all of you, the agencies, to provide a review of your portfolio that you have. If you think you have 10 buildings, 5 buildings, multiple buildings that you think might fit this criteria, we'll do the heavy lifting and looking at the site requirements and cross-referencing that with the attributes of your buildings that you're trying to get approved. Site will need to work with the BEM controls to clear cybersecurity requirements, as well as have an engaged building staff that is able to perform the control sequences that Wise Building provides. We would also like stable occupancy, operations, and internal loads throughout the validation timeline to provide an apples-to-apples comparison of how the building was operating before the field validation project and how it's operating now. Lastly, we would like full documentation of as-built drawings of the building and mechanical systems, electrical systems, as well as control system and control sequence documentation as well. Next slide, please. So this is a breakdown of the responsibilities for the owner or the building operator that decides to enroll in this field validation project. Is to participate in a 1-year-long study, maybe a little more depending on lag and purchasing and installing equipment or commissioning. But the first step would be to purchase, install, and set up the BIM compatible hardware. So this is anything that's basically you know, the smart thermostats, the smart lighting, smart plugs, anything that you're buying to be compatible with the WISE Building software needs to be purchased by the customer, then installed. After 6 months of running the building with the new hardware, then we would go in and install the BIM software, the WISE Building platform, for another 6 months. So installing the platform, you know, optimizing the dashboard, getting everything, all the control sequences tuned to the building operator's needs. After running that for 6 months, we're able to really capture the incremental value of the WISE Building platform provides. So as I mentioned earlier, we were really looking for a building that has mechanical control, really rudimentary analog controlling of you know, thermostats, lighting controls, things like that. For the, you know, the next 6-month period, adding in the hardware is going to provide some value, you know, by itself, given that these new systems are a little more intelligent, can provide set points and scheduling for these building systems, and then going in and installing the WISE Building platform itself is going to provide another bit of incremental value. So we're really trying to tease out, you know, energy savings, operational costs, energy costs, as well as things like thermal comfort and occupants comfort, as well as, and I think this one's really important, building operator or facility manager satisfaction of the WISE Building platform itself. So, you know, like I said before, the building operator, we really would like the facility manager to remain engaged and properly operate these WISE Building control sequences, as well as you know, interface with the dashboard itself. A big question for small and medium commercial buildings is who is using this platform. I know for large buildings there tends to be a facility manager, but for this smaller sort of part of the building stock, it's a good consideration to see who's actually going to be looking at this every day, or, you know, a few times a day. So that's something that we would be talking about in detail in the recruiting process for the building. Yeah, so that's basically it for me. Thank you so much, and look forward to hearing your questions. Thank you.
Thanks, Armando. And I just want to say that this has been selected as part of the GPG program, for those of you in GSA who had a couple questions here. And so we have a good process with the GPG program for doing cybersecurity analysis. With that, let's move along to the next slide, Marissa. And I'd like to introduce Robert Hart from LBNL as well to talk about thin triples. Robert, can we hear you?
I hope so. You got me?
Yeah, take it away. Thank you.
All right, great. Thank you. Yeah, I'm Robert Hart from LBNL. I've been working on or leading this project on thin glass triple pane windows for about 3 years now. Initially, our focus is on residential construction. We saw that as a kind of quicker path to market. Residential windows are usually smaller, and a few other reasons why we took that path. But now at this point in the technology progression, we're starting to look at commercial windows and the applications in commercial buildings. So we see right now is this kind of prime time to get some commercial windows demonstration projects going and understand the benefits in commercial buildings. Go ahead, next slide, please. So the technology itself is fairly simple. We start with just a typical double pane window, which is pretty standard window now in the market. And then we drop in a thin piece of glass right in the center. And the thin piece of glass, it's anywhere from, say, this 0.7 millimeters, which is something you'd see on your big screen TVs or your cell phone, up to 1.2, 1.3 millimeters glass, which is a kind of something you maybe more see on windshields or windows in your cars, those sort of things, or picture glass. That goes right in the center. What you do then is you now have 2 air gaps or gas gaps instead of 1. doing that enables you to add a second low E coating, which increases the efficiency of the window. And you end up with the glass performance about double what the old double pane unit was. Now, the advantage of doing this type of construction versus a traditional triple pane construction is really, there's kind of two main points for that. Is you save savings on weight. So these, just because the glass is thicker, you save significant weight, which in turn gives you another advantage with in the framing systems. So triple pane framings typically have to be much more robust to handle the additional weight of three standard layers of glass. But they also have to be quite a bit thicker. So with our traditional thinner walls we have in North America, these type of windows don't always, standard triple pane windows don't always fit in the typical walls. And then another benefit of this is if we're looking, with these type of buildings, if we want to go in and do a retrofit, say your window frames are in good condition, but the glass is failing, or there's some other issues with the glass and the glass needs to be replaced, we can come in and replace that existing double pane glass with a triple pane, so much higher performance glass, but leave the frames in place. So this gives you a lot more options in the retrofit market than are available with standard triple pane. Go ahead, next slide, please. So in terms of performance, what you can see with this type of retrofit is if you have fairly good frames in place, again, you go in and put this glass in and you do a argon fill, which is pretty standard in the market now. For glazing, you can see a kind of full window performance, and not center of glass, but full window, including the frame, of around an R4 point U of 0.25. This is compared to a traditional kind of commercial building glazing now is around R2 to 2.5 or so. If you go in and put in a really high performance frame, you do krypton fill in the gas, things like that, you can get up to an R5, and that's using commercial framing. And depending on the building type, we can put this in several different building types. If you can use a more residential or light commercial style window, you can get to an R6, R7 performance level of the window. Solar heat gain coefficient and visible transmittance, which is something we always get questions about. These are just as tunable as they are with any double pane unit. If we wanted to go in and only, say, replace a floor, retrofit a floor of a building, if you have a 2-3 story building, or just certain facades of a building, if we know what the glass is that's in there now, we can fairly well match the aesthetics from the outside. So there won't be any issues with that going forward. And of course, all that's really dependent on the location specifics to your building, which we can work with you in figuring out what the right combination of glass is for your building. Structural performance, again, I mentioned that we had started this as kind of residential focused, and so we're moving our way up with testing past the residential sizes. So you can see a picture here of a 50 square foot thin triple being tested, pressure tested to failure. So we've done quite a bit of testing of these larger sizes, but we still want to work our way up slowly to those. So again, this kind of work that we're looking for here with these demonstrations, we'd like to keep them in the kind of commercial window 30, which is DP 30 or pressure rating of 30, which is typical of low-rise, mid-rise commercial. You think your multifamily, hotels, apartment buildings, those type styles of buildings that we're looking at. The glass itself, this thin glass, is a non-structural layer, so we don't consider it actually in the design pressure of the glass. It just floats in the center. It's not carrying any load. So you design the outer lights of glass just as you would traditionally for the requirements of your building. The one other caveat here is that this is really for vertical applications. We don't want to put any sloped glazings or skylights just because the glass is so thin. It can sag if it's at held at a horizontal or for too long. Go to the next slide, please. So some of the benefits, I guess maybe the main benefit that we see for going to triple pane glazing in commercial buildings is really comfort. I'm sure a lot of you know the occupants are the most expensive part of the building, and really so their comfort is very important. Showing here is a kind of image of Minneapolis Design Day. So we're looking, I should mention a little earlier, for this technology. Initially, we're looking for colder climates, say climate zone 6, 7, possibly in some into 5, depending on the location, to really kind of highlight the benefits of this technology. And really, when you go to a triple pane glazing, even on design days such as Minneapolis is shown here, you can be comfortable right next to the window. And what typically happens with definitely with single pane, but even with traditional double pane units, is when it gets very cold outside, many of us have experienced this, we get the draft coming, you can feel that cold draft hitting you. Often that's not just air leaking through the window, that's actually the glass surface getting cold and then the cold air falling to the ground and moving through the building. So you feel that draft. With triple pane performance windows, that glass is significantly warmer, typically the same temperature as the walls, or very close. And you no longer get that draft, which makes occupants much more comfortable, allowing you to move. If you have problems with the occupants having to move their desks away from the walls, you can actually move those desks back to the walls, regain that square footage, and be much more comfortable in the space. The other advantage of this is not necessarily typical for retrofits, but a case we see with newer construction. You can actually increase window size now, which it obviously helps with daylighting and other factors for comfort. Go ahead, next slide, please. So of course, we always talk about energy when we talk about a higher performance envelope, and of course, the higher performance windows are no exception. One of the biggest benefits we see out of this type of technology is that if you have a very well insulated facade and very high performance windows, you're actually able often to eliminate perimeter heating. And so this is a case, this picture showing a case where this building, and this is an airport, you can see it was able to eliminate, or in their designs, they could eliminate this perimeter heating by going to a triple pane window. That gives you significant cost savings. So the incremental cost of the triple pane technology or the thin triple technology is much less than it costs to install perimeter heating. So one thing to consider here, if your building if you're planning with your building to do a HVAC improvements or retrofit in the next several years, upgrading your facade or your glazing now to this level of performance will enable you to potentially reduce your HVAC sizing, eliminate that perimeter heating when you do that future retrofit of the HVAC. So you can make significant savings in the future. A few other the benefits, of course, is that when you have a more insulated or a higher performance building, it's more resilient. If you lose power or something like that, the building will stay comfortable longer. You reduce your peak heating, cooling loads. You have a more stable load to the utility, and you reduce warm-up time. So if you have setbacks at nights, or if you have a setback over the weekend, your morning warm-up times can be reduced significantly. And these are all kind of items that we obviously be looking for to validate through this testing. Next slide, please. So again, just a quick summary of some of these expected benefits. Of course, we're looking to reduce the total energy load to the building. Really want to show the improved occupant satisfaction and comfort, and that ability to regain that perimeter zone area for comfort. Reduce warm-up times and loads. If you are considering going to a triple pane level performance, before this, definitely look at the thin triple. The much easier installation, the reduced weight eliminates a lot of those issues that have been associated with triple pane windows. And of course, the HVAC capacity downsizing and perimeter zone elimination potential. And next slide, please. So just a kind of final quick summary of some of the site requirements that we're looking for. Low-rise office is a kind of general building type we're looking for that can be varied depending on the uses of the buildings. I know there's a fairly broad audience here of use types, but that style of building, this low-rise office, so small to medium size. The window frames, we typically, ideal case for these windows would be what we call a punched opening style window, which is what you would consider like the windows you have in your house, typical just the window in a wall scenario. That would be the ideal case. We don't want to do anything like the high-rise type style windows. If you were looking to do a full retrofit of the frame, you're having issues with the frames and not just with the glass, we can look at doing the very high performance, such as fiberglass or something like that, window frames. Part of our monitoring, of course, just similar to the last presentation, metered performance of the HVAC, some metered performance of selected windows. We don't need to do all of them, but it's good to have selected windows monitored, and monitoring a few of the desk areas of people that are in the area, some surveys of the occupants to determine their satisfaction going forward. And then, of course, historical building energy use and energy use during the test period. And that's, I think, most of what we need. Again, most of these other considerations are pretty similar to what you heard on the last presentation. And I'll just ask Marc LaFrance from DOE if he has anything to add.
Yeah, sure. Thanks, Robert. You did a great job. So I manage the window R&D activity at DOE, and I think Robert covered all the key elements. Just a couple of points I'd like to make is, if there are hospitals, low-rise hospitals, the comfort factor for patients could be significant. And if it's some other applications, if you're looking to try to achieve a zero energy building, thin triple or triple pane windows could be a major benefit. And also there's a lot of areas that people are trying to move towards electrification with a lot of heat pump applications. And if you're moving towards that and you start having pretty high electric resistance backup heat, I mean, the windows can play a key role in reducing that peak wintertime load. So any kind of major building upgrade, you really need to do the windows first. So there could be some, a lot of advantages to go to a triple pane. In this case, a thin triple is even more viable than a regular triple. But when you start looking at those holistic approaches, the cost of going to a triple can literally be zero compared to going to a conventional window when you take out the cost in the other areas. So anyway, I just want people to think about these various applications. And when we say cold climate, that's our key focus. But if you're trying to achieve a zero energy building, then a mixed climate also makes a lot of sense as well. So just some things to think about. So thank you.
Great, thanks so much, Marc LaFrance from the Building Technologies Office at Department of Energy and Robert Hart from Lawrence Berkeley National Lab. Next up, we have Greg Lamm and Eric Werling, who are going to talk about minimally invasive insulation from the Building America program. I'm sorry, Doug Lamm. Doug, can we hear you?
You can hear me, and thank you for the correction.
Take it away.
All right. Yeah, this is Doug Lamm, Building Envelope Materials. I'm going to present a technology for a new type of minimally invasive retrofit insulation of buildings. This is a technology that was developed over the past 4 or 5 years, primarily by my company, but also in collaboration with Certainteed. And then we had a huge amount of help from the Department of Energy through a grant we received a couple of years ago. The original intent of this technology, I'll get into the details in a sec, but the original intent was to figure out, is there some way that we can get really significant energy savings like you would get in a deep energy retrofit, so sort of in the 30 to 40% range, without all the expense of a deep energy retrofit. And those normally involve tearing off siding, putting foam on the outside of the building, and all of that sort of thing. So as we got into it, we we quickly realized that most of the cost was related to the walls. There's, the technology for attics and roofs is pretty well established, but walls were a major problem. And we also discovered that even though single family is a good opportunity for us, the buildings that have the biggest problem with walls are obviously tall buildings or larger buildings, at least. They tend to be more wall dominated than homes are. So if you could go to the next slide, please. So the basic concept of this technology is really, really simple. Essentially, we drill a 1/4-inch hole in a wall, and we fill a cavity with a very highly insulating material that's similar to what many of you know as spray foam. Our material is a little bit different from spray foam in the sense that it has a different catalyst in it and it has a different blowing agent, but it provides basically the same benefits. It gives you this very high R, 6.5 per inch R value. And really the trick to the whole process is essentially to calibrate the amount of material that we're putting into the wall. So you could take two cavities that are identical in two different buildings and inject them with the same amount of material, and they'll rise differently because every building has a slightly different moisture content and temperature profile and other things that affect the rise of material. So we do a calibration process where we take all of those factors into account, and then using that calibration, we can figure out exactly how much material to put into other cavities. In addition to sort of the basic process of injecting, under the DOE grant, we were able to develop what we call the talking rig. So if you're familiar with regular spray foam, typically there's a big truck with a hose, and then you pull the hose into the building and you spray material into open wall cavities. That's fine, but it doesn't really address very large buildings, and we're typically doing 8-story buildings and things like that. So we needed a mobile unit that we could actually bring inside the building. And in addition to greater mobility, we wanted something that was really easy for the technician to use. So with many systems that have a display on them, it's very hard for the technician to inject and to look at the display at the same time. So we developed this talking system which tells the technician exactly how much material, audibly tells him how much material is put into the wall. And in addition to that, it does one other thing that's really important, which is that it tells us what the quality of the material is that we're injecting. So these materials are two-component systems, and we have to get the ratio correct of one side to the other. And so this system actually monitors the ratio every half second, and it tells the technician if he's off ratio or on ratio. And if he's off ratio, it tells him what to do to fix that ratio. So those are the two main components. At the bottom of the slide, you can see on the left there a picture of what a typical hole looks like. We can fill those holes with lightweight spackle. It takes about 30 seconds to fill the hole. Very simple operation. We can inject into either empty cavities or cavities that have fiberglass insulation in them. And in fact, the vast majority of what we've done is injecting into cavities that have fiberglass insulation in them. That's really important because that accounts for about 75 or 80% of all the buildings that are out there. We can also validate the fill. So unlike, say, cellulose, where you inject the material and you're not quite sure, if the whole cavity was filled, our material actually heats up a little bit when it goes into the wall. So because of that heating, you can validate the fill with an infrared camera. We can actually see the material in the wall. We almost never get any voids, but if there was a void, we could see it easily, and we can just punch a hole and fill it. And then if you talk to contractors and you tell them about what we're doing, a lot of them initially would say, well, I don't want to do that because, you know, I'm going to overfill a cavity and blow out the drywall. So without getting into a lot of detail about how we address that issue, we have a system for virtually eliminating the potential for drywall blowout. We've injected probably 10,000 cavities and have never had a blowout. Next slide, please. As far as applications go, we've done a lot of brick veneer multifamily buildings. That's really an excellent application. They're tall, so they're very hard to do with any other technology. You have to do them from the inside because you typically can't do retrofit insulation on the outside of a building like that. So any sort of masonry or brick veneer is an excellent application. We can, of course, do under-insulated single-family homes. Shallow cavities in the mid-Atlantic region are very common. That's typically strapping over a concrete block or strapping over a brick. We can do those. Historic structures. The Guggenheim Museum was actually injected with closed-cell polyurethane foam. That wasn't by my company. It was a different process, a very invasive process. But certainly historic structures where you can't change the exterior of the building would be a great application. And then older office buildings would be another excellent application. Next slide, please. As far as costs and benefits, typically we are able to do these buildings if it's fiberglass filled at about $5 to $6 per square foot. And that is just for the area that we're injecting. So that's per square foot of injected wall area. In other words, it doesn't include doors and windows and other parts of the wall. And then the benefit is we have so far one really good case study on a benefit, and you know, we're hoping that we can do more through this program. But in this case, we injected 8 units in an 88-unit apartment building in Providence, Rhode Island. And I'm sorry, we monitored 8 units in this building, and we injected 4. So we had 4 injected units and 4 uninjected units. And then we compared the HVAC runtime in the 8 units. And what we found was, as a function of temperature, of outdoor ambient temperature, that the injected units had about 25% less HVAC runtime than the uninjected units. So that was, and it was temperature dependent, as you can see on the graph. So that was really encouraging data. Obviously, we need to get a lot more data, but that was really a nice start. Next slide, please. For site criteria for this project, you know, I mentioned the types of buildings that would be good opportunities: brick or masonry veneer, under-insulated fiberglass cavities, which could be in virtually any kind of building, and then shallow cavities. Those would be the 3 big application areas. HVAC, we would prefer electric, and the only reason for that is that the benefit in an electrically heated building is much greater than it would be for gas or oil. We're doing a lot of electrically heated buildings right now for the Boston Housing Authority, but gas and oil is okay as well. We would prefer not to have single pane windows in the building. The previous presentation that you saw went through all the reasons that single pane windows are a problem. We really want to isolate the advantage of the insulation versus the window. So double pane would be better. And then relatively high energy use intensity or relatively high energy cost would be preferred. This is going to work better in colder climates, so climate zones 4+. And then the other requirements would be very similar to the previous 2 presentations you just saw. We'd like to be able to have utility bills for at least 2 years and do additional monitoring for at least a year after we've done the installation. And I think that's about it for me. Thank you.
Great, thank you so much, Doug. Eric, I just want to give you an opportunity to say anything that you wanted to add.
Thanks, Amy. I think Doug covered it really well in terms of the opportunity. I think it's a potential game changer for certain types of buildings, and to think about how can we retrofit buildings with existing technology cheaply and effectively is something that we've been struggling with for a while, and this is one of the few technologies that I've seen that can help us with that. So I'm pretty excited about it. Looking for ways to get the technology validated outside of the Boston area where Doug has done most of his work. So looking forward to any interest we can generate in potentially collaborating with us to field validate it elsewhere. That's all I have for now.
Great, thanks. Perfect. Okay, so it's time for question and answer. I'm going to go ahead and read these to our presenters and get those answered for you. But you can type them into the chat box, or you can type them into the questions box. I have quite a few here. So I will start with Armando, just to give everyone else a little breather. First question, Armando, is around the size of the buildings for the BEM control technology. So can you talk a little bit about why smaller buildings are what we're looking for?
Yeah, that's a great question. So in terms of the small building part, I think what we're really trying to do, and like the highlight of BEM controls and WISE building, is that it does provide a service for a portion of the building sector that hasn't been really seen before, and kind of the contribution to the research, right, is that in and of itself. So we're really trying to highlight what these technologies can provide this particular section of the building stock.
So easy to install and enable, where maybe some more sophisticated energy management systems aren't as available or accessible.
Yeah, exactly. Yeah, there's a lot of advantages that this provides in terms of flexibility and over optimizations in these buildings that is already pretty well documented in large buildings as well. Yeah.
Great. Okay, Hayes. Is there money to support the purchase and installation of these technologies? There are two questions related to different technologies, so I think we could roll it up into both.
Sure. So in FEMP, we are looking to partner with the sites on installation and hardware. So I think, looking for different partnership opportunities throughout BTO FEMP and other ongoing activities that you may have on your site. So I would say if folks are interested, let's set up a more detailed call to talk about your specific circumstances offline, and we can get into more details there.
Great. And as a follow-up, how many sites are we recommending?
Sure. So we are, casting our net wide with this call. We're really looking to focus on 1 to 2 sites per technology. I think each of the presenters has done a great job of outlining the type of scenarios, some of the building characteristics that would be best for each technology. But right now we're thinking about 1 to 2 sites per technology.
Great. Okay, so maybe a question for both Doug and Robert and Eric and Marc. And that actually, the question came in while Robert was presenting, so it was, I think, related to the thin triples, but is as relevant as we heard yesterday in our webinar to the insulation. And that is, how do these mitigate, manage, control, address thermal bridging in the wall and in the window, both? So let's start with Robert and Marc.
Sure, I'll take that. This is Robert. Yeah, so I guess thermal bridging, like when you talk about the windows, there's a few places for thermal bridging. We don't plan on going into the wall, so if you're looking at your headers and things like that, we're not looking to address any of the wall cavities. The main part we think about with commercial windows with thermal bridging is the frames themselves. They typically use aluminum frame in commercial buildings. So if you already have a good, say, thermally broken aluminum frame in your window, you can look at that and say, is it bad enough or good enough to keep performance-wise? If it's not, you can look at going to a different, newer, higher performance one. If you have a standard unthermally broken aluminum window, it makes sense to pull that out with the rest of this retrofit. Most of these products, and particularly the ones we're looking at here for the thin triplet, are using warm edge spacers. So your perimeter of the glazing system itself is fairly good at eliminating the bridging.
This is
And
Marc.
Marc,
The only thing I would add is,
right.
Yeah, the only thing I would add, so some people might be aware of this, when we look at a new window, whenever we talk about a window, we're talking about the whole window U value, or we're talking about R values. And so that takes into account all of the performance of the entire window system. So, which of course includes thermal short. So when you say we're going to go from an R2 or an R3 window to an R5 window, that's taking all that into account. The only exception would be when somebody puts on a secondary glazing system, which is a recommended retrofit when you can't afford it, you don't plan on putting in a new window. I mean, that doesn't need to be field validated because it's already been done with GSA and other folks. But when you install a secondary glazing system, you would try to install like a thermal block that would isolate the thermal short of the aluminum frame for a secondary glazing system. But, in this case, we're not really talking about that. And then my colleagues will talk about, there is the possibility of doing, exterior insulation and cavity insulation at the same time for a very high performance, but I'll let them answer that. So.
Great, yeah, so Doug and Eric, any thoughts on that question?
Yeah, well, I would just say, and I'll let Eric add to this, but I would just say that, our technology really would be used for two reasons. One is if you basically can't do exterior insulation. So in other words, if you have brick or masonry veneer on the outside of the building, exterior insulation is really, really difficult or maybe even impossible. So that, those sorts of applications are ideal for what we do. And then, and secondly, it's just speed and cost. We can do, with a 3-person crew, we can do 3, in a multifamily building, we can do 6 apartments per day. So it's a very, very quick process and very inexpensive compared to putting exterior insulation on the wall. So I don't know, Eric, if you have any other thoughts on that.
Yeah, we are, we're working on a whole host of potential solutions for reducing the costs of insulating the exterior of buildings in colder climates going forward. A lot of those solutions won't be ready for a few years, but that doesn't mean that insulating the cavities of buildings can't do a tremendous amount to reduce the energy consumption for heating buildings now, and there's absolutely no reason why you can't do both in the long term. So that's my take at this, is that improving windows now, improving the cavity insulation now, and then maybe removing the thermal breaks later when the technology gets cheaper is a very rational approach to gradually achieving deep retrofits to our buildings. And I think that's how we ought to look at it.
Hey, Eric, if you don't mind, this is Marc.
Yep.
The reason why I'm just going to add one last thing is because I did manage this work for 10 years. And the idea is exterior insulation will never be cost effective for insulation. However, if somebody decides they want a whole new facade, a whole new look to the building, and they're going to do that anyway, then, I mean, they're going to do that, then adding the exterior insulation makes a lot of sense. But the cavity insulation is a no-brainer for energy efficiency. It's like the first thing you need to do. And it doesn't mean you couldn't do both. You could do cavity insulation now, and then 10 years when you want to put a new facade on, you then add exterior insulation and have a very high-performance wall. So I just wanted to add that tidbit. Thanks.
Great, thanks, guys. Okay, I'm going to move on to one specific to insulation. Doug, are there VOC implications associated with the insulation, and how are you managing and remedying those?
Yeah, we get this question very frequently, and I probably should have put a slide in on that. So we've had 3 rounds of independent air quality testing done from third parties while we're actually injecting. So basically, you know, at the sort of worst case scenario. And what they found is that there's virtually, while we're doing our work, there are virtually undetectable particulates from our work. Our material comes out like shaving cream. So it's not like spray foam, which comes out as a fine mist. So you don't get all of these aerosolized particles floating around in the air. And those are really the biggest risk, at least certainly for workers and also for building owners if they were to come back into the building too soon. Now, VOCs is a slightly different topic. That's often referred to as off-gassing. And in one of those 3 studies, we also monitored VOCs. And immediately while we're doing the work, there are very, very low levels of VOCs that can be detected. Within 24 hours, there are virtually no levels of VOCs that can be detected. So, so the VOCs really are not a big deal.
So this is Eric from DOE, and I just wanted to add to that, indoor air quality has been a major component of the Building America research strategy for many, many years, well over a decade. And I actually worked at EPA for a few years before I came to DOE in 2011. So VOCs are an issue that are important in spray foam applications. But the one thing I'll say with this new technology is that the improvement in accuracy of the application of putting the Part A and Part B together, and I believe, Doug, you mentioned the talking rig feature that helps to ensure that the technician is getting feedback about whether or not the mix is proper. That's the greatest source of VOC risk associated with spray foam currently, and this is an improvement on that technology. That doesn't replace the need for workers to use the proper OSHA protections while they're doing spray foam activity. So, you know, you have to make sure that the job is being done properly. But I think that spray foam, just like pumping gas, can be done safely and in a way that, you know, reduces exposure to practically zero for VOC exposures. And certainly it's a good idea to keep any, you know, any occupants out of the building for that 24-hour period when those, just to be, you know, cautious, et cetera.
Great, thanks a bunch, Eric and Doug. Okay, next question for Robert and Marc. Thank you all for so many questions, by the way. I'm trying to juggle all of these questions and figure out a good order to ask them so that everyone has a little bit of a break to think. So does deploying as part of a larger project potentially make it harder to isolate the impact of the triple pane windows? Really good question, I think, especially because some of our other window demonstrations have been maybe just one wall or one work area. So thoughts on that, Robert and Marc?
Yeah, I mean, definitely anytime you add more variables, you you make it harder to isolate them. So yeah, it would make it more difficult. I'd say the comfort impacts, which is one of the things we want to focus on with these measurements, should still be fairly easy to isolate. But you know, wouldn't be as perfect. But Marc, I don't know what your opinions are on if you think it's okay to add additional ones at the same time, or staging, or.
Well, I think that it does create a challenge if you add other measures, right? But and also when you try to see what's the impact of the window, we could do individual window monitoring, like heat flux transducers. We could do things like that. But if you're looking at the holistic building, and if you install, let's say, a new heating system at the exact same time, which is a good thing to do, and you downsize the heating system, then you're going to have to do some disaggregation modeling at the end to attribute the benefits to the window versus the heat pump or the heating system. But it certainly can be done. It also has a lot to do with the baseline window. If you're going from a very, very poor window, then the savings are going to be dramatically larger, right? So, but in the modeling, we would say, okay, well, what were the savings additionally compared to a double pane low E window? And we would show what those savings are, but then we would say the savings that you realize in your building was significantly greater because maybe you had a single pane window or a double clear window. But all of that can be done through modeling to attribute the savings from the different measures. But it's not easy, but the national labs do this all the time. I mean, they're experts at it.
Yeah, and I think that's always a question with validation. Where can you model versus where can you try in a real building to inform that modeling? So balance between the two, one being much more expensive than the other. So, but also eliminating lots of variables, as Robert mentioned. Okay, next question is for Hayes and Amy. So will we be assigning a DOE staff person to coordinate work between the site and the labs? And Hayes and I have agreed that yes, we will. So I think this comes from Andrea Silvestri, who works on the GPG program, knows these projects quite well and how complicated they can be. So yes, we do plan on having support from the DOE side to help move these forward and make sure that things are coordinated. Hayes, anything I missed there?
No, I think that's a great point because I agree. There will be lots of coordination needed and lots of details to work through, but look forward to it.
Okay, and then another question that came in here towards the end is around whether these are applicable on installations. So Hayes and I agree that we think this means all entire facilities. And in the commercial buildings program, we refer to commercial buildings as including federal facilities, and we break that down by sector, which is maybe how you can look at it on a military installation as well. You have lots of different kinds of buildings on your installation. So, for example, a dormitory may be similar to a multifamily the terminology that we might use in the commercial space. And we work pretty closely with Tim Tetro on the ESTCP program as well. So we've talked about how these technologies can translate to military installations as well as private sector commercial installation, as well as federal agency buildings or across the federal portfolio. Hayes, anything else to add there?
No, just wanted to point out that, yeah, I think commercial buildings is sort of a broader umbrella term at this point. And then as Amy pointed out, the federal stack, is composed of both commercial and, to some degree, some residential and other types of facilities. But we are interested in getting federal sites that meet the criteria that each of the, or federal facilities that meet the criteria that each of the presenters talked about to participate in this validation.
Thank you. Okay, let's see. So we do need to end right at 1:15 Eastern, 11:15 Mountain, 10:15 Pacific, because there's another webinar starting directly after this, and we want to give Marissa time to set that up. I am going to take one more question, and I think I'm going to ask the about experience in commercial facilities with the injection insulation, or for Doug and Eric, if you guys have done this in multifamily yet, or other, I think, applicable commercial buildings.
Yeah, we've done, I don't know the exact number, but I would say somewhere around 10 to 15 multifamily buildings. This is primarily affordable housing. So we can, those are not a problem at all. Office buildings are very often constructed like large multifamily buildings. So those would be, just very similar to buildings we've done in the past.
Okay, great.
Right.
Okay.
Yeah, I would just add for clarity that the type of the building envelope is more important for this technology than the type of space. So the slides that Doug provided on the types of buildings are probably more important to look at than the usage, the space usage.
Very helpful. Thank you, Eric. Okay, so Marissa, do you want to take us to the next slide, and I will turn it over to Hayes to wrap up.
Perfect. Well, thank you, Amy, and thanks, Marissa. And so just wanted to follow up with everyone. These have been some great questions. If there are additional questions that we have not addressed in the Q&A at the end here, just due to time reasons, please feel free to reach out to me. And if you are interested in talking to us, talking to some of the points of contact here in more detail about specific sites, to answer site-specific questions, or if you're interested, please feel free to reach out to me by email. My email address is on the screen, and look forward to talking with you more. And just wanted to say, everybody stay safe in these the current circumstances, and thank you so much for joining our webinar today. I really appreciate it. Thanks, everyone.
Thanks, Hayes. Bye.
Thank you.
Bye.